Okay, I hope you did not black out chapter 3. So if you forgot how to treat things, like what if we have a velocity in both the x and y direction, like a projectile, at an angle for some reason? If you remember that at all, then actually this will be okay. But if you don't remember it, then you need to refresh yourself. So in an inelastic collision, remember glancing is just our code word for at an angle. So that's no big deal. We're going to target that. And they don't start out at an angle. Mass number 1 is only going the x direction. So you could say like Vx equals plus, is it 20, 30? Okay. And we got a mass 2 that has a Vy, and it's plus 15. Then what do we do? What's a perfectly inelastic collision? We know two special things about it just from that word. Sure. They're going to stick together. Okay, that's the only glancing collision that we're allowed to do in honors physics, the only angle collision, because if we don't, if they bounce off each other, then they have two answers and both at an angles, and it's a giant trig problem. It's just a huge mess. Okay, so rest assured, we do glancing problems, and they're very similar to this. What else do we know about inelastic? Something about conservation of physics properties? Oh no. How about sure, Allison? Okay, kinetic energy is not conserved, so don't even worry about that. Just throw it out. Is anything conserved? Okay, momentum is always conserved. So the momentum is going to be the same. You could say P final, and these are totals, by the way, equals P initial. So if I turn these things into momentum, and then they have a collision, I know the total final momentum is actually the same as the sum at the start. Okay, so that's not so bad. Okay, now here's the tricky part. I'm going to do momentum of thing 1 and thing 2, just like Dr. Seuss. Initial. And it has only x momentum. So this is vector momentum. Do you remember how to write that from way back in chapter 3? Take like 10 seconds and try to write it. There's a few blank stares. What was chapter 3? It was about projectiles, where things could move up at an angle. Like I kick a ball up at an angle, and I have some angle above horizontal. Uh-oh, here it comes. So my favorite way, we could do any vector, was to draw these angled brackets and have Vx comma Vy, because that looks like the xy points on a grid from Algebra 1 class, and that's very, very similar to what it really is. Okay, there's some special rules. We can only add or subtract momentum from momentum, or force from force, velocity from velocity, so we do have to do our physics. We have to make sure we have the same thing we're working with. We can't add momentum to velocity. That's a big no-no. That'll get you like half credit at most on a test question. But if we make it momentum, then we're okay. So the x component of mass 1's momentum is how much? 30,000. So it's 30 velocity has 1,000 kilos. So let's write it out. Plus 30, it's heading to the right, 30,000. How much in the y direction? 0, my favorite number. And I like to write the units outside the bracket if we care. There's newtons or kilogram meters per second. It's nice to remind yourself that that's momentum, and we can't just add velocity. Okay. Here's momentum of object 2 initial. Okay. Oh, it doesn't have any x momentum. And its y momentum is also 30,000, but in the y direction. Hey, wait a minute. Gotta scroll. So if I add those vectors, and they stick together, what did mathematically, in physics equations, what does stick together mean? It seems really obvious, but then you can't say it. Okay, we do have to add the masses. Momentum has to be conserved, or we probably wouldn't be working on this problem. It means that V1 final equals V2 final. So when we might have done a momentum equation, so momentum is conserved, I can't get rid of any, whoops, and I forgot a bracket right there. I just have to have P final. I don't have to have 1 final, 2 final, or anything. They stuck together. So I just have 30,000 in each category. Okay, this is like P final X, comma, P final Y. If I'm feeling super generous on a test question, I'll just ask for the final momentum. Yeah, well, we wrote it down in its vector paired forms. They started out going in straight lines. They combine, and there it is. Okay, but we wanted the final velocity. So it's a little more complicated than that. Not much, though. Okay, so we added our vectors together. It's a combined, we're in the final stage now. So it's a combined object, like Landon said. So V final is just P final divided by the total mass. Okay, so let's see, my total mass is 3,000, isn't it? Combining them, I can't see that part of the problem anymore, but so you just divide each piece by 3,000 to get your vector, and it can stay in vector form. So it's plus 10 and plus 10 meters per second. Okay. If I'm feeling grumpy for some reason, I might ask for the trig. Like if I feel, I don't know, I'm already feeling like maybe you need the review. Like I would ask for the magnitude and direction of its final velocity. Oh. Well, if we have our old, whoops, why didn't I put X on the vertical? Wow. Okay, if I have our old pals, the XY axis, these are just two vectors that go 10 on the X and 10 on Y. They're added vectors, right? Just in different directions. And so your final would be, your hypotenuse would be 10 times the square root of 2. Right, so I could also write my final velocity as, what would that be, 14.1 meters per second. At what angle is that? Yeah, at 45 degrees. Okay, and I'm always nice enough to, if it's not a 45 degree angle, I'll make it something simple, like probably 37 or 53 or 30 degrees. Something easy. You just keep X and Y separate. Make sure you know which object is X and Y, because I can have the intersection going any way. Some of these could be negative. Okay, but then just do your little XY cross, figure out the angle. Make sure you divide by the total mass. That's the one thing people tend to forget is, hey, can't I just take momentum and use that? Not quite. Not if I asked for the final velocity. Okay, and you can't divide by one mass or the other. Most people can remember, okay, momentum is mass times velocity, I can divide momentum by mass, get velocity back. But they stuck together, so you have to use the total. Okay. Any questions? Alright, I'll leave that up. I think it's time to cut my video. Yeah, because we're over 10 minutes.